I've been into hi-fi, I like to say, my entire life. And I mean that in a way literally, because I'm an identical twin.
Oh.
I'm not only an identical twin, I'm what's called a mirror twin, or we are called mirror twins. So first part that is, he's left-handed, I'm right-handed, which means we were born as a stereo pair. Right? Myself and my brother, we were geeks. We got into electronics, pre-teens, got into hi-fi around that time. My dad had one of these stereograms, all-in-one that goes across the corner. And when he was looking to upgrade, we said, oh, you're supposed to buy separates. So we persuaded him to buy everything in one, but with a pair of speakers on and cables. So we got more and more interested in hi-fi. For some reason that I've never really fathomed, I got interested in speakers. So all my effort as a DIYer in those days was towards building speakers. But what was interesting about trying to build my own speakers was experimenting with ideas. I remember at the time a speaker that was very popular in the UK was the Jim Rogers JR149. It was basically an LS35A, but built into a cylindrical aluminium. I'm talking about England, so I'm going to say aluminium. Aluminium tube with wooden end caps. I thought, that's cool. I'd like to try and build something like that. It did not work, but at least it was a teaching experience. In my mind was the fact that, well, suppose I finish this build. How do I know it's right? It kind of didn't occur to me to think it doesn't matter as long as I like it. But my viewpoint was, okay, I can build something. I just don't know when it's right. How do I know if it's right? Well, maybe I should be able to measure it. I'm a teenager. How am I going to measure? So I started building my own test gear. I've got a Tandberg tape recorder, so I use that microphone that comes with it, which definitely not, not a reference microphone. But it was a start towards thinking about how do you measure things, and that stayed with me for the rest of my life. I even built a discrete time delay spectrometer after I'd read the paper from Richard Heil about time delay spectrometry. And I built one from discrete components, voltage controlled filters and oscillators and things. Decided to go to university to study physics and acoustics. And my final year project was a linear phase loudspeaker. Then I did postgraduate research in computer-aided crossover network design, new algorithms for doing the computing of the crossover network. My brother, I joined him at his research group. After that, 3 years research in noise control. So instead of making noise, I was trying to cancel it. Me, I was doing like big speakers to go on ships to cancel the noise from the funnels, using ATC bass drivers, 18-inch, 15-inch bass drivers, for which I got a relationship with Billy Woodman, who founded ATC. And then I joined KEF. So for the next 11 years, I was at KEF. And KEF was my speaker university. You go to university sort of to learn how to learn. After that, you need tutelage and mentorship in the particular subject that you're really going to specialize in. And for me, that was at KEF. The two companies in England at the time that had the best research facilities, B&W and KEF. For me, KEF was the one, and I got offered a job by Laurie Fincham, who was the technical director at the time, and that's where I stayed for the next 11 years. I joined the Infinity Group. 3 years later, I left because I was offered to head up speaker design for Pioneer. And to a lot of my friends, that was a very unusual choice. Why am I going to work for a Japanese loudspeaker company? We know, the pervading feeling was that, well, the Japanese can't design loudspeakers, which, if you know what all the research that had been done and published in the AES journal, you realize got some of the best engineering in the world. If it wasn't commercially successful at the time, it was more to do with design choices, not engineering capability, right? I knew of all their research, and I was just itching to get my hands on some of that. You know, my thought was, with what I know about loudspeakers, what they know about loudspeakers, if we can work together to steer it in the direction I want to go, if I'm given that freedom, which I was, but to get access to the engineering potential they have, that would be fantastic. And it was. I stayed there for 17 years. And during that time, I launched TAD Home. TAD Pro had been around since 1978, doing beryllium compression drivers, with the engineering help of Bart LeCanthi, who was at JBL originally. And so I was kind of the new Bart LeCanthi to start a home division using beryllium but in concentric drivers, because ever since the days of KEF and helping develop UniQ, I was convinced of using concentric drivers. 17 years later, 5 years ago next month, I joined ELAC. And that was a chance to start a new division of an existing hi-fi company from Germany, to try and get some success in the US, because ELAC had been around since 1926, actually. And ELAC stands for electroacoustic. And they started doing acoustical engineering, but underwater acoustics at that time, from the late 20s onwards. Sonar, that kind of thing. And they switched to doing audio. And speakers, turntables. We know ELAC here from the Benjamin Miracord turntables. Very successful. So by 1985 was when they first started seriously with speakers. Although they've been extremely successful in Europe and the rest of the world with speakers, they never gained the foothold in the US for speakers that they had for turntables. And so 5 years ago I was approached with the idea of setting up a US division, kind of subsidiary but independent from a design point of view, to start designing speakers based on what I know, and especially to start with more affordable stuff, which they had never done and didn't have the capability to do. And I did. Coming off, both doing the high end with TAD, but also those Pioneer speakers at $100, $120 a pair. It just turned out that, oh, we'll do that with ELAC. So that led to the original debut series. I'm going to talk about this particular set of speakers. I'm going to play some music. So these are the bookshelves. I'll tell you what they are shortly.
Those sound like floor standers.
Yeah.
They do not sound like
That's
2A.
That's one thing that I'm going to discuss why they do. But I thought these were particularly a useful thing to be able to talk about, because there's lots to explain, because it's a powered speaker. People don't generally buy active speakers. Partly it's because I'm removing choice from you, right? You like to choose your power amplifier. If you're a tube enthusiast, you might not like the choice of a solid state power amplifier. You want either a Class A or a Class AB, or let's say even a switching amplifier of late, because they've finally come of age and they are a quality, high-end product. Removing that choice is both an issue because unless you're building your own stereo components, your participation in your system is choosing and playing with all the different components to get the sound that you want, right? And I'll come back to this, it's the sound that you want. It's not necessarily the correct sound. Right. I'll have a big conversation about that at one point. So you're choosing what you want to hear. Also, very few of us just go out and spend, let's say my TAD system, when I had all electronics with it, it's a $250,000 system. You don't just go out and buy a $250,000 system. Even if you have got to that stage where all your parts are worth collectively $250,000, you got there gradually by trading up. And anything that stops that trade up is a problem. So you've lost choice by not having the amplifier built in, but you've lost the freedom to upgrade, because if you've got a powered speaker, Or if you want to upgrade to a powered speaker, you're not only trading in the speaker, you've got to trade in the amplifier as well. Plus, potentially the dealer's lost some selling capability to you, because instead of selling 2 pieces, sells 1. So there's a resistance there. That contributes to why it hasn't really caught on. But in the position I am of, yes, I've done very high-end, I've also done very affordable stuff, and one of the driving ideas behind doing affordable stuff is that I want lots of people to be able to access good sound. But we're trying to get new people into the hobby and younger people. So how do we do that? We need to look at what people are buying. And if we look at everybody who we want to try and get into the hobby, they're either listening on headphones, or what they're buying just plugs into their computer. It's an all-in-one speaker. It's everything in it. Plus they want connectivity, simplicity. Now some of us, I'm finding, are looking towards simplifying, as long as we don't really lose sound quality. If I want to attract newer people, I want to move towards some of the products being of the kind of thing that they're used to. Once we can grab them, maybe we can progress them into this side of things, or just higher quality of that side of things. So what is that? What do they want? What can we provide? Can I do it without eliminating the traditional market as well? So that's what this is, and I'll start to explain. So let's talk about active versus passive. Start by doing a passive speaker. So we have a multi-way system, first of all. Why do we have a multi-way system? If we say the ideal loudspeaker is a point source radiator covering the whole frequency band, great idea conceptually, absolutely impossible from the physics. And we can't cheat physics. I'm a physicist, I know these things. To produce bass, low frequencies, we have to move a large volume of air. For every octave we go down, we have to move 4 times the volume of air in order to maintain a particular sound pressure level. So bass needs a big bass driver, well, not in this case, but I'll get into that. A big bass driver moving a large distance. So it's the swept volume, area times displacement, to produce the sound pressure level we need. We don't have to do it very fast because it's only bass, but we do need that volume of air. High frequencies need a small amount of movement, but very fast. So one can be a big heavy thing, and it's got to be heavier because it's got to move a lot there. Tweeter has to be very light, but can be because it's very small. Those are opposite extremes. So a tweeter can't produce bass, and a woofer can't produce high frequencies. So we split it into a minimum of 2 ways. To do that, we need a crossover network. And we like to, when we say crossover network, it's as though all it has to do is filter off the high frequencies from the woofer and the low frequencies from the tweeter. But it's way more complex than that, because it has to equalize the drivers. There's no such thing as an electrical network that should be a Linkwitz-Riley or a Butterworth, because the driver has its own non-flat frequency response and roll-offs and phase shifts. When we talk about is it a Linkwitz-Riley type approach, what we mean is electrical in to acoustic out has a shape that's maybe a classic Linkwitz-Riley. But the electrical network absolutely will not be Linkwitz-Riley. So we've got to design this network that both rolls off in the right way, but also equalizes the driver and works into a non-constant impedance, which is the drive unit. And if we're thinking about a third order system, a 3-way system, like this, we're crossing over somewhere in the 200 to 250 hertz range for the woofer. Well, a vented box will have an impedance characteristic that has a bump, let's say at 30 or 40 hertz, a minimum at the tuning frequency, let's say 50 or 60 hertz, another peak at 100, 120 hertz. So you've got to have all sorts of compensation components in there so that it will still give the shape that you need in that crossover range. So it gets to be quite complicated. It's a bit easier with a two-way system, but three-way systems get quite difficult. So lots of components, they're big and heavy, they have losses, and just difficult to optimize into that load to work right. And on top of that, once you've got it working into that load and giving the shapes you want, the impedance seen looking into the speaker can really go wonky. So one of the jobs as a speaker designer of a passive speaker is I've got to take care of that. I've got to be able to make the impedance as seen by the amplifier relatively benign. But it's never going to be easy. So that's the job, that's the difficulty of designing a passive speaker. And because it's got to be universal for any amplifier, because amplifiers are all designed with a flat frequency response. They're not tailored to a particular speaker. So sensitivity, bass response, impedance, we can't play with those. They are given to us. There's a universal law which ties box size, bandwidth, and efficiency. Well, by bandwidth I mean low frequency response. Box size, low frequency response, and efficiency together. I can choose two of them, the other is given to me. So suppose I've decided I want a box of this size, and I want, let's say, a sensitivity 90 dB. Then I can't get bass out of it. Maybe 50, 60, 70 hertz. That's all I can get. There is no other way of doing it. I can cheat on impedance. That's cheating. I can make it a 2-ohm speaker, but that's not the right thing to do. As people wanted smaller and smaller subwoofers, there's only one way around it. As you put it into a smaller box, you've got more stiffness in the box that you've got to overcome. You've got to put in more power. More power is expensive in the old days. These days it's sort of dirt cheap, certainly in comparison. So you look at these compact subwoofers, they're claiming 1,000 watts, 2,000 watts. They can push that much power to overcome the small box to get the bass you want. You've got to design the drivers suitable for that, but you can sort of cheat the laws of physics if you're designing them together. So that gives you a clue about active speakers. We can cheat what would have been required for a passive speaker with a regular amplifier. So that's what I'm going to explain next. Yeah. I've said how subwoofers gain an advantage from being matched, amplifier to woofer. In the region where the woofer would be rolling off, you put boost in the amplifier. So as long as it's got enough power and the voice coil can take that power without thermal compression, then you can sort of cheat. So in this, we can do the same thing. It's a small woofer, but as you heard, performs more like a tower speaker. If you design the woofer right, and the electronics are exactly matched to that woofer. In an active speaker, let's say a three-way, we talked about the complex load impedance that the driver presents to a passive crossover. But when it's directly connected to an amplifier, that's a much easier load, typically, than if it's driving through a crossover network. And like I say, we put in the EQ to get whatever bass response we want from that cabinet within reason. The other thing is when we are designing, let's say, a three-way system with the amplifiers there, each amplifier is only operating over a limited bandwidth. So there's less overall intermodulation distortion within each amplifier than if it's a single amplifier driving the whole bandwidth. And in the range where we're rolling off the driver, its impedance is also rising, so a double help in minimizing out-of-band power required to drive into that particular drive unit. And when we look at music as opposed to test tones or sine waves, we all know that music has got peaks and average levels, the peak to mean ratio. highly compressed music can have a peak to mean ratio of maybe only 8 dB. Dynamic music could be a peak to mean ratio of 15, 20, maybe a bit more dB. What that means is you've got peak demand and average. The average is the power, the heating power that you're dissipating. The peak is you've got swing that volts momentarily into the speaker. That ratio of peak to mean changes with bandwidth. If you took a broadband music signal, put it through a filter and looked at it, the temporal characteristics, and you narrowed and narrowed that filter, if the filter gets narrow enough, there's only a sine wave coming out. And that's a peak to mean ratio of 3 dB, 0.707. The wider it is, the larger the peak to mean ratio. It just so happens also that at low frequencies, the peak to mean ratio tends to be smaller on average than mid and high frequencies. So tweeters need a lot of peak power for, let's say, a cymbal crash. But the average power that you're putting into tweeter is a couple of watts, 3 watts, 4 watts. It's very rare that you're putting a huge amount of average power into a tweeter because you've got limited bandwidth and limited average power. It's the opposite way with the woofer. So we can design the amplifier not only for the frequency range that we need, but for the time characteristics that we need. So we can optimize them for the bass unit, mid-range, and the tweeter. So that's a further advantage of doing actively. What are we giving up? I said we're giving up choice, right? It's solid state, it's not tube, is one obvious choice. I've also got to decide what kind of solid state amplification I'm going to use. You'll find that most powered speakers these days use Class D amplification. Because if I need power to overcome the small box, how do I get that power packaged small enough and efficient enough to go into a speaker like this? Class D is much more efficient than any other technology. It can approach 95% efficiency. Now the amplifiers are in here, they're all packaged into the cast aluminium base. So that slanted section there is an aluminium casting housing all the power electronics. 150 watts on the base, 100 watts on the mid-range, 40 watts on the tweeter. The tweeter is a Class AB amplifier. Don't care about efficiency there because the average power is so low. So although it can swing enough for sort of a 40 watt capability, it's never pushing that amount of continuous power. Mid-range and woofer are what we call bash amplifier technology. It's a Class AB amplifier that's made efficient. If we look at a regular Class AB amplifier, the maximum efficiency it can attain is 67%. Class D is 95%. That doesn't sound that much different, really. But what we've got to remember is it's what's left over that matters. In a Class A amplifier, only 5% is lost as heat. In a Class AB amplifier, let's say 35 to make the number easier, 35% is lost as heat. There's 7 times more heat dissipated than in a Class D amplifier. So we only need relatively modest efficiency improvement to get a huge reduction in waste heat and waste power. So what a bash amplifier does, it's of the form of class of amplifier where instead of having fixed rails, voltage rails for the power amplifier, we modulate them to be only just enough for the instant that we need that much swing from the amplifier. Now the trick is, it's got to be fast enough, because if it's not fast enough, you're going to clip the signal. So it's kind of got to know in advance what the signal's going to be. So that's the tricky part. But you can kind of work around that, partly by having a little extra voltage headroom to first of all be okay until the power supply can catch up. You also make sure that the power supply bandwidth for changing is faster than the amplifier bandwidth. And that's easier when you've got limited bandwidth because crossing over at 250 Hertz or 2.5K. So they're efficient amplifiers, not as efficient as Class D, but efficient enough so it can package a total of 300 watts into that small enclosure. Right? as individualized, optimized for the particular drivers. So we get to this question of, I have taken away choice from you, at least as far as your power amplifier goes. So what am I giving you in return? What I'm saying as an engineer, by me making a choice of building the amplifiers in, now of course you've got the problem if something fails, you've lost the power amplifier and the speaker, you know, and it can be worse than that, I'll get to that. I've been able to build something from an engineering point of view I could not have done, certainly at that price point, with a passive system that is universal. You know, any amplifier can go with my speaker. What does that restriction in choice mean from a sound point of view? Let's forget commercial right now, about sound. You listen to it, whenever you listen to something, let's say you just listen to a passive speaker, and you go, oh, I like that, or, oh, I don't like that. You listen to that speaker system, you make a judgment as to whether you like it. You don't start questioning, typically, the parts that are in that speaker system that you're auditioning. You either like it, or you don't. So what I'm saying is, I've made a choice of the electronics to give a package that is only one step further up the chain that gives a sound. If you like it, you've still got the choice of everything else upstream. You've lost one choice, that's it. Now, of course, you might be so into tubes that nothing ever driven by a solid-state amplifier could come to the sound that you like. That's okay. You know, I don't pretend that I've got the speaker that everyone in the world will like. I only ever design what I want it to sound like. It's just fortunate that enough people like that to make it a business. Removed only one section of choice, and if you like what you then hear, go with it. You still can play with everything else. So to aid that, this is a purely analog design. It's an analog active crossover. So it's a kind of old style active speaker. There's no DSP in it. Right? That was a deliberate choice. Because I want to appeal, like I said, to both crowds, traditional audiophile and new people. So the first decision is, should it be everything all in one? So let's leave it analog. Because what does a digital crossover, a DSP crossover, do for you that analog can't? Actually quite a lot. The question is, do you need it? You know, it's this idea of just because I can doesn't mean I should. Analog crossovers, you can only get certain frequency shapes with it. The more complex shapes you need, the more cascade of circuits you need. You can't separate out phase from amplitude. It's a minimum phase system. A DSP crossover has the ability, oh, and you've also got component tolerances and manufacturing tolerances to worry about. And every time in a development process, if you need to change a filter to listen to it, you've got to pull components out, solder new ones in. With a DSP, you decide on what shapes you want to fix anything you want, press a button, load it into the DSP, you can listen to it. There are no component tolerances to worry about. You can have very high slopes of the crossover, 8th, 10th order, no problem. You can give it a phase response that is separate from the amplitude response. All these things. But the question is, do you really need to do that much? Or rather, if you need to do that much correction to the drivers in that cabinet, haven't you got rather ratty drivers to begin with? Shouldn't you really fix it at source rather than afterwards? It's a three-dimensional device. It's not like an amplifier that one output for one input. It's one input with a multi-dimensional output. It measures different in every direction. Some of those things you should not be fixing for one particular direction. Diffraction effects. They will be different in every direction. Resonances radiate differently in different directions, but can show on axis a little, but be worse off axis or not. Those things you shouldn't be just correcting with a single point measurement. So you kind of do an average So nothing's right, but nothing's quite as bad. Is that the right thing to do? So let's try and fix it at source. So I can get away with analog crossovers. I do analog, but that doesn't give me any extra connectivity than any other traditional analog active speaker. So what I also build in is a wireless receiver module. While I'm in an analog mode, switch to either balanced or unbalanced input, the wireless receiver is powered down, so it cannot interfere. When I switch to wireless input, it powers up the module, and now there's a little transmitter box that goes with it. That box is a Roon endpoint, Spotify Connect, Bluetooth, AirPlay, DNLA, but you've got all this extra connectivity. So that any way that you're playing your music, you can connect wirelessly to this on a proprietary wireless connection. It's not on the Wi-Fi network, so it's synchronized automatically between the two channels. It's not like the KEF where it's wireless, but to keep timing between left and right, you've got to connect a cable between the two. So it's wireless, and anything you want to play through it. So you've got the best of both worlds. You can buy it as a purely analog, traditional speaker without having that box, or you can add the box to it, get all the connectivity you want. And what's interesting about that is the people who actually want that. A few months ago, I was asked to go and visit Steve Vai, the guitarist. He's got a studio, actually only 20 minutes from my house. He wanted to listen to these speakers. But one of the first things, because he'd heard about what the speaker can do, I'd got it rigged up to his mixing desk so he can listen to it compared to all his regular monitors. And one of the first questions he does, he comes in, sits down, introduces, and we have a little chat. Then he pulls out his phone, his iPhone. He says, I have some music on here, can I play it on them? That was the first thing he asked to do. I said, no, because I didn't bring that part, because that's not what I thought was going to be the first thing you asked to listen to. But so often, he wants to know what it sounds like with that. So we got into this conversation I try and have with everybody. What do we mean by hi-fi? Closest approach to the original sound. Great concept. Pretty much worthless, because there is no original sound if you're reproducing over two channels. There cannot be. Spatially, the way you hear in a live environment is never reproduced properly over two channels. Even the apparent tonality, because it's coming from a source to the left and right of you, the head-related transfer functions tell you it fills in and you get a stereo image, but tonality is not the same as what appeared in the original event. Then the original event has to be captured with microphones. It's kind of down to what you prefer, right? So when I'm designing, I try and know what do I prefer, and then if you like that, that's fine. If you don't, that's also fine. But it's down to that personal choice, particularly, especially with low-cost speakers. I'm big on measurement. My whole life has been developing measurement techniques, all the days from KEF. I know how to measure very accurately. The question becomes, what measured response do I want? Let's say flat. I'm not actually going to get flat, not in affordable speakers. So it's down to, well, which area do I give up trying to improve, and which areas do I prefer to improve? That's a personal choice. Now, the curves tell me which areas are wrong, but my personal choice of what to fix is down to me. So measurement isn't enough in that sense when it's not perfect. It's personal preference of what I fix and what I give to you. One more piece on these, and we'll set up these. I'll explain the difference between the towers and the bookshelves.
What kind of source material are you using? Like resolution type?
I'm using a mix. Most of it these days, I used to start off by playing an awful lot of, hold on, high res. But as digital's got better, and especially with Peter's electronics, our position is going to be a bit of a guess here. So.
Can you tell us about the power supply in those speakers?
So, it's a switching power. Let's imagine it's a Class D amplifier used as a power supply. You know, the characteristics of the amplifier don't filter through into the circuitry, but that's what allows you to modulate the supply rail fast enough to power the Class A B amplifiers.
Oh, each of the amplifiers have the same rail voltage?
Close. Yeah, there's not that much difference between 150 watts and 100 watts.
I have a question. When you voice your speaker, how far from the back wall do you usually keep it?
I experiment with that. With the lower cost speakers, especially bookshelves, they're likely to be used quite close to a back wall. So I try and, allow for that, which is why Debut Mark II went from rear vented to front vented, so that there was a bit more freedom as to how close to the wall you put it.
What happens if you put the speakers up against the wall like most people do?
So
How much
there's
change?
EQ switches on the back to adjust treble level, mid level, bass level. Bass level either 0, +1, or -4. That's for when you're close to a wall. And the others are +, -1. So either adjust it to the acoustics of your room, or if you don't like the sound they've given you, you can change it.
Andrew, we've had a question about what the stand mounts cost. And maybe you could tell us what the floor standers cost too.
Oh, good point. $2,000 a pair for the stand mounts. So that's 3-way concentric driver, of course, 1 woofer. Towers are double that. 3 woofers, bigger cabinet. The overall power is about the same. You'd think that for a tower speaker, I'd need more power. The reality is different because I said that relationship between box size, bandwidth and efficiency. I've got 3 times the volume. So I've got efficiency to spare. So in a simple thing, if I take 1 woofer's, design bookshelf, let's say, then I put in the tower 3 of those identical woofers and I wire them in series from a measurement from a distance. If I put a certain voltage in and measure the frequency response, I cannot tell whether I've got 1 woofer or 3 identical woofers in series. Sensitivity does not change. Because they're in series, each woofer gets a third of the voltage, but a third times 3 is 1. It's exactly the same. Now, off-axis, high enough in frequency, it matters, but these cross over at 250 hertz, so it doesn't. But the impedance is 3 times. So it's 3 times the efficiency. So, either I change the amplifier to have the same power, but swings 3 times the voltage, but only needs a third of the current, or I use the exact same module, and I rewind the woofers to be 12 ohms instead of 4 ohms, and put them in parallel. And then I've got exactly the same system as I had before, but 3 times the efficiency. So I can go a lot louder in the bass, both because of the efficiency and because I got 3 times the area. So I can produce a lot more bass output capability.
Were all the woofers enclosed in their own little cabinet?
So it's sectioned off here.
Right.
So this is the bookshelf, let's say, with its own vent at the back. The lower chamber is 1 single chamber, double the volume, 2 woofers, 2 vents, so the tuning gets back correctly.
I was hoping you'd play that
The front one gets the shrapnel if I got the volume right. So the intention with the speaker is it's supposed to sound just like the bookshelf. It's kind of, I mean, I'm paying double and it only sounds like the bookshelf. But one of the problems when you're designing a series loudspeaker, especially with passives in the old days, maybe you have 6 speakers in the range. You have a 5-inch two-way, a 6-inch two-way, 8-inch two-way, or dual 6-inch two-way, and you have a centre channel, and then you have all that duplicated as towers. They often sound totally different. And maybe they're supposed to, because they're supposed to get better. On the other hand, if it's better but very different, what are you trying to say to people? That that's a range of speakers? Shouldn't they just be different model numbers? The other way is to try and make them sound identical, but what you gain is output capability, bass, loading into the room, dynamic capability. So it sounds better because it's less strained, more open, more dynamic, but tonality is maintained. So that's what I try and do with these. And so I always design the bookshelf first, get that right, and from that develop the tower.
How long does it take you from the beginning to the end of the process, usually?
It depends on the complexity. So sometimes it's quite fast. When I joined ELAC, I joined February 17th, demoed the first prototype B5 at the Los Angeles show on June the 1st.
Wow.
That's starting a brand new company, having prototype ready by June. Production or in store by October for the whole range.
Wow.
2 bookshelves, centre channel, 2 towers, couple of subwoofers. So it can be very quick. Something more complex like this, it can take quite a bit longer. But the problem is I'm never developing one speaker to completion, then doing the next one. Because there's a lot of downtime while you're waiting for prototypes and things to come in. So you've got so many different projects, especially me. I think I've designed close to 60 speakers in the 5 years, maybe even more than that I've been with ELAC. So it's a lot.
The speakers get good reviews, that's the important part.
Yes, they do. And what was interesting, doing it at the low price point, a lot of the review, you've got the traditional review was, Absolute Sound, Stereophile, the print magazines. But there's a whole load of reviewers out on the interwebs that I'd never heard of, that got product for review. But you get requests from all sorts of people I'd never heard of. But you have to have faith in what you've done and just hope that people will hear for themselves what you think you've built into that speaker. And so far, pretty much 100%.
Yeah.
So I count myself fortunate with that. Great company, that. Thank you. That ends the formality of it.
You might want to let them know what the pricing is. Everybody's probably wondering.
Yeah, so $2,000 a pair for the bookshelves, $2,000 each for the towers.
Oh,
But you don't need your power
And
amplifier.
what about the little box that enables it for streaming?
$400
Oh, okay, that's like
to add all the connectivity that you want.
Well, let's give him a hand. That was a
If you-
probably could squeeze in some Q&A.
Yeah, if you've got questions, don't make them too complicated. I might not be able to answer them.
Are you going to develop a center channel that goes along with this?
We haven't yet. It's a trivial process. If you think about what I said about having developed the bookshelf first, it's 2 woofers instead of 3 or instead of 1. The difficulty is the bottom of that amplifier is not a visually attractive piece, and you know, if you turn it on its side, you've got this sloping amplifier on one side. What do you put some dummy and then do you put end caps on? You got that thing to deal with. We could easily do it. The reason we didn't first is we're trying a new market. We're feeling our way to see, and we found so far that this idea of making it traditional audiophile, but with the capability of expanding to make it connected, is working really well. So we've seen very good sales so far. And you know, this idea of appealing to the traditional market, we're finding that a lot of people are going, you know, I've had my fun with all the complexity. I know I want good sound, but I want to get some simplicity. And so we've been finding some people who bought it because of that. So we looked at it as sort of an experiment of doing this. And as we see success, we'll see what more we can add. We've had some requests about a center channel. So we just want to see how real, what commitment, because it's one thing for someone to ask, do you have one? Will they actually buy it? We have to be persuaded of that.
Andrew, I don't want to put you on the spot, but when you're at home and you want to spend some quality time listening, what do you listen to?
My TADs, my very first Model 1, the laminated camera.
And that's the floor, the big
Floor
one?
stand, yeah.
Okay.
Yeah. Although in a way, my favorite version of it was the compact reference. It's just a wonderful combination. It's a stand mount. It's got all the virtues of the big speaker without going quite as low, but it's sort of my favorite ever speaker.
Okay.
Why are compression drivers more popular
Why are they more popular where?
for speaker designers? Why aren't more speakers
Oh,
designed?
why aren't they?
Right.
Okay. Limitations. Compression drivers, the primary focus of a compression driver is super high efficiency, very high sound levels. For PA systems or studios with the far-field monitors, you know, the in-wall things where they do want to really play very loud. Or in a home situation, rather than being able to play really loud, the fact that they are very efficient, but very directional, which can be an issue. Horns are only efficient because they're directional. They trade sound everywhere for sound in front, based partly. So you can play very loud with a low power amplifier. So you'll find Japan, huge, or Asia in general, huge market for horn style compression type drivers with small tube amplifiers. But it's a small market, right? I've not developed consciously to go for a very small market. You know, with starting with TAD, I could have gone the route of taking the TAD compression drivers that we'd already got and modifying them for home use. I chose not to, but to do something more universal in the way that most people think of hi-fi. The difficulty, especially believing in concentric drivers, it's very difficult to get a compression driver to work over wide bandwidth. It's typically a decade, and you just shift that around. It's very difficult to get a compression driver to go out to 40K, for example, should you need to. And if you could, it would only go down to a K or something. There are some concentric compression drivers, a little tweeter in the middle of a ring radiator going into a horn. They're a bit raggedy in response. For me, the best compression driver is the TAD 4004, but you're still restricted to crossing over about 500-600 hertz. So then you've got some lobing problems when you cross over that high. So there's merits and demerits, and it's just for the markets I intended to go to, I don't use compression drivers. I'm not against them, and there are some qualities that are outstanding that they have. Especially it's a compression driver, but they don't have compression, if you see what I mean, which is a good thing.
What are the pros and cons to having an external amplification module to the speakers?
Apparent versatility. You know, suppose it was a crossover brick that a passive one, that you could upgrade at some time and change to active. Or you do the Lin name approach. You have amplifiers that are universally, you just buy 3 amplifiers, but you've got an active crossover module tied to that specific speaker. That keeps the complexity, or more so than doing a regular passive crossover with a single amplifier change and play. So that's
What I was asking more, let's say, for heat dissipation for the tweeter, you put a Class A amplification, Class AB for the mid-range, Class D for the bay, but you need a bigger box, like especially for the bookshelf. So if you have a separate unit with a specific cord that you plug into it, and then in case something went wrong, you could always interchange to find out if there was something wrong with the speaker.
Well, certainly an aspect of, once it's built in, if something goes wrong, it's more difficult to fix. But it's not that difficult. All the power amplification is built into that bottom module. You just unscrew it and put another one on.
Okay.
So that's not so difficult. In terms of, would you upgrade what's in there? They're already matched to that drive unit. That's the whole point. So it's very difficult to think that I would change the amplifier module without doing a new woofer, for example. So.
So between these active speakers and your Adante,
Yeah.
one thing I love about when I saw the videos, and I've actually heard a pair before, is that funky bass sound. No, it's brilliant, don't get me wrong. What would you say the comparison between these active speakers and those?
So, remember how I was talking about, with a passive speaker, you're limited in what you can do within, let's say, the laws of physics. So, what that Adante base loading technique was give me a little X factor improvement. When you go from closed box to vented box, you can gain something. In that equation, you've got a constant times box volume bandwidth efficiency. That constancy factor is lowest for a closed box. It's better for a vented box. So for a vented box, you can go either up to 3 dB or more sensitive, or efficient, half an octave better bandwidth, smaller box size. That's a good thing. When you go to that coupled cavity method, that constant factor is a bit better. So you can do a bit better. But once you're matching the amplifier, I can cheat in that sense. So I don't have to use that technique. So I don't, because it's very complex to build.
Do cables make a difference?
Not getting into that. You know, so let me say that my upbringing, all the days from KEF, and being a physicist, a scientist, let's say, scientific method. So if you're going to establish, does something make a difference, you need to do fully viable, let's say double-blind experiments, let's say. You've got to get a methodology to do that. You've got to do a single-valued experiment, which means you've got to be absolutely confident that you've only made one deliberate change which you're going to evaluate. And the failing of a lot of scientific research is unexpected consequences of the design of the experiment, where they thought they changed one factor, but they changed a number at the same time. So you're always fighting against that to get it right. Doing, let's say, double-blind experiments, very complicated, time-consuming, most people don't do it. Now, I've done experiments with cables where I'm convinced it makes a difference. Can I explain why? No. I don't like to be in the position of not knowing, and therefore promoting something that I thought make a difference, but I can't say why it does, or did it absolutely. So when it comes to talking about cables, I'm not going to say they do or don't absolutely as a scientist. I can say a couple of times I've thought I've heard a difference. Convinced.
So how did it sound?
Well, that year it sounded really good. However, there was some new equipment there. I'd switched the room around 180 degrees, changed the acoustic treatment. I'd done a lot because I always try and up the game every year. Even if most of the equipment is the same, I want to improve what I've done. So The system sounded fantastic, and I cannot tell you that it was the cables.
You weren't curious enough to hook up some zip cord?
No. Don't have time to. It takes me long enough to get good sound in the first place.
All right, well, how about one more question from somebody who wants to be?
You have, say on the acoustics of the room, do you use the voice, are they the same as like you have at home, or do you have a special analytical process for evaluating?
Yeah, try as many rooms as I can. Yeah, I got some room treatment at work. I got actually very little at home. It just sounds nice. I do all the shows. You know, I like to think I'm good at taking a day and a half and getting a good sound, or good enough sound, out of almost any room I'm presented with. So I often take prototypes to the shows. Even like that first debut of Debut. It was a prototype. Not quite finished, but I don't mind telling people this is a prototype. Especially because if they like it, great. If they don't, I go, yeah, I know, it needs work, but... But it gives me a chance, by going to all these shows, evaluating how best to set speakers up in rooms, how to treat them, so I have a good feel for what I can do.
Well, thank you again. Yeah,
Right.
a delightful speaker. Thank you all for...
So what's in the future for you?
Wouldn't you like to know?
That's why I asked.
Come to Expona! Come to Expona, you'll see.